thank you for the introduction. So I'm Evelina Gobasova, and I'll be talking about exploring Stack Overflow. Oh, so first of all, I am in no way related to Stack Overflow. I just use it. That's my only connection to Stack Overflow. In fact, when I was doing this work, I was connected to University of Cambridge, where I was doing a postdoctoral researcher job. And I'll be talking quite a lot about Fsharp today. And if you have never been to Cambridge, you should definitely go, because it looks very beautiful, and it's the home of Fsharp. But then you look at the photo like this, and you say, oh, so nice. But, well, I was working here. So let's not talk about this anymore. I was actually working with biologists. I was working in bioinformatics, applying machine learning methods for analyzing biological data. And working in bioinformatics is extremely interesting because you get to work on things like cancer, and you get to dig really deep into biological foundations. But sometimes the data that I was working with looked like this. And you really can't see anything there. I can't see anything there either. So whenever I did something, whenever I ran my algorithm on some data, I had to go and then talk to a biologist and say, OK, does this make any sense? And they usually were able to construct some kind of story, even if it wasn't true. So they said, oh, OK, yeah, this connects to this. Yeah, this definitely makes sense. But this really didn't tell me if my algorithm is working or not. And that's quite a problem. So what I started doing in my free time, I started working and playing with some more interpretable data. For example, I played with Star Wars. Who likes Star Wars? I do, definitely. So I constructed a social network of Star Wars characters from the movies. Like I extracted screenplays and extracted who's talking to whom, and I created a social network. So I'm really looking forward to the new episode now. In December, so that I can add more characters to the social network. And this was fairly successful. This basically led to my publication that was read probably by the most people ever, because as an academic, you write papers, and if 5 people read them, you are very happy. So this actually got published in the French version of Scientific American, Pour la Science. And I was so excited. I got the article, and I looked at it. And it said, Evelina Gobasova, Université d'Oxford. I don't speak French, but I'm pretty sure this doesn't say Cambridge. So let's go back to Stack Overflow. So why Stack Overflow? Why did I choose Stack Overflow to play with, where I could play with something like Star Wars? Well, everyone works with Stack Overflow. Everyone uses it, mostly or, well, on a daily basis, at least I do. So I thought, OK, that's something to relate to everyone. So let's look at the data. And what kind of data can we get from Stack Overflow? Well, Stack Overflow has a developer survey, which is quite interesting. They do it annually, and they ask developers to fill in a survey, and then they publish the results. So I thought, OK, that might be an interesting data set. But then I looked at it, and I work in data science and machine learning. So, for example, this is most popular languages by occupation. And for data scientists, it says that the most popular language is JavaScript. OK, well, everyone uses JavaScript to some extent. But, for example, the 5th most popular language in data science, according to the survey, is C#. OK, I don't actually know any data scientists working with C#. And then PHP is here, and it's more popular than R, which is a language used a lot in data science. So I thought, OK, maybe this data set is not so reliable. And then I looked at the most popular developer environments by occupation for data scientists. And apparently, according to Stack Overflow survey, most data scientists work in Visual Studio. I don't know if you know of someone doing data science, but they probably don't use Visual Studio. And yeah, Notepad++, I'm not sure you can do things like plots in Notepad++, to be honest. Well, and things like, for example, Jupyter, which is an environment that a lot of people use in data science, doesn't even figure in the top 10 for this. So I thought, OK, this is strange. So maybe I should look at different type of data. Then you can get their API, which you can use to query all the data on Stack Overflow. But that's more sort of for like, getting specific information, like what questions are people asking regarding a certain tag, etc. They also published their data on BigQuery, but I decided to go a different way. They actually also publish a data dump of the entire Stack Overflow. You can download that. It's freely available on archive.org. And you can download the entire dump of all Stack Overflow, entire Stack Exchange datasets. And that's quite a lot of data. So I just downloaded the Stack Overflow part. And this is when I listed it on a command line. And you can see that the biggest file, well, this is an old dataset that I was using. And there, the post history, the third one, had 67 gigabytes. And it's a single XML file. So that's quite cumbersome to work with, right? Altogether, it was about 120 gigabytes of XML files. And XML files are not the most friendly datasets. So I basically just took some of them and pre-processed them into CSV files, because I'm a data scientist and I use CSV files. So now that I got 120 gigabytes of data, I thought, OK, so what can I do with it? I have a lot of data. And this happened to me at work quite a lot, where a biologist came to me and they handed me a hard drive, 6 terabyte hard drive, and said, OK, here is your data. Like, what should I do with it? And they were like, I don't know. It's the data. The data will tell you something. And if you have 6 terabytes or 120 gigabytes of data, it's always the same. You can't just let the data tell you something. You actually have to ask questions. So this talk is partly about how you should use your curiosity to basically look at data and play with them if you want to do some data science work or just play with some machine learning algorithms. You have to ask questions. Otherwise, you will get nowhere. So I thought, OK, so this is a sample post on Stack Overflow. This is actually the first ever post on Stack Overflow. It's asking about form opacity, if it's a decimal or double. So I thought, OK, so what kind of information is there? Like, what can I use as a data scientist? And the nice thing about Stack Overflow is that all the questions have tags. And for me, as a data scientist, that's amazing, because I know what's the topic of each question. So I thought, OK, I will look at the tags. That's exciting. So I can ask questions like, what are the most common tags? Well, that's a question. It's not a very interesting one, because that's something that Stack Overflow tells you directly. If you go on the main page of Stack Overflow, it tells you, OK, the most common is JavaScript, the second is Java, the third one is C#, and then PHP. OK, not very interesting. But then I realized it also tells you, OK, this many questions were asked today, this many questions were asked this week. So I thought, OK, maybe instead of asking what are the most common tags, I can ask when are people actually asking questions. Because, for example, I use Fsharp quite a lot, and if I want to ask a question, maybe I want to know when should I ask it so that people actually answer. So I thought, OK, let's look at this. So my first question is when. And during the talk, I'll be showing you some samples of Fsharp, because that's my favorite language when I want to do something from scratch. And as I said, I processed things into a lot of CSV files. So this file that I have here, tags time for CSV, it actually has about 1.5 gigabyte of data, which is not gigantic. It fits into RAM, but it still takes some time to actually even load into RAM. So it's not very practical to just open the file in Excel or something and look at it. So what I can do in Fsharp, Fsharp is a functional language, and it's very nice for working with these sorts of data in an interactive way, because Fsharp has something called type providers. I'll just type something, and I will explain what I'm doing. So I will take this file, and I will create something called type provider. And because it's a CSV file, I will create a CSV type provider. So now I have a type that's defined by my CSV file that's rather large. And what this does, it goes into the CSV file. It looks at the beginning of the file, first a couple of hundred lines, and it infers types of each column in the file. So now, when I actually want to work with the file, I will actually load it. Get sample. This will load the file. And now I can look at rows. And because this is a functional language, I will use functional constructs. So I will use a map. And if I look at the row, and I do row dot, it tells me that in the file there are actually 3 columns. First of them is day of the week, second one is tag, and the third one is time, when a question was asked. And for example, the time, this is .NET, so it's system.datetime. And I didn't have to do anything. I didn't even have to look at the file. I just loaded it, and it tells me, OK, it contains information about the tag, like a question that was asked, which day it was asked, and what was the specific time that the question was asked. I have all the information here. And you can see that it didn't load the entire file into memory, because that would take quite a long time. So I won't even run anything. So this is incredibly useful when you are working with large data files, because you don't actually have to load them. You can write your program. It type checks, because this is a functional language with static type inference. And it's correct. And after you have it written, you can actually run it. And you can be pretty sure that it will run. So I basically used this to extract days of the week and tags of questions that were asked. So this is an example for Fsharp, because I was using with Fsharp. I looked up Fsharp first. So you can see that most questions are asked Monday to Friday, and then on Sunday and Saturday it drops. So that's the weekend. People are spending time with their families, not working, so they ask less questions. Then I looked at C#, and you can see that it's quite similar. But the difference between Fsharp and C# is that the difference between the weekday and the weekend is slightly different. Can you see that? People ask less C# questions on the weekend than they ask Fsharp questions, relatively speaking. I thought, aha, that's interesting. That means people play with Fsharp much more on the weekend than they play with C#. And I thought, maybe I can see how fun a language is based on how many questions people ask on the weekend. So, for example, this is my friend Chris, who actually develops the Fsharp plugin for VS Code that I'm using. And here he is working on Fsharp open source stuff on the weekend. Because quite a lot of people, when they work on open source, they don't do it as a part of their daily job. I thought, OK, maybe that will tell me also something about how languages are used. If it's more like a corporate language that people use only at work, or if it's something fun or open source or more open that they would play with in their free time, maybe sitting on a mountain. I'm not sure. That's probably not very healthy. So let's formalize this a little. My assumption is that during the weekday, these are the questions that people ask when they are at work. This will be fairly similar between Monday to Friday. Then these are people that probably play with some language in their evening work. So that should be fairly constant across the whole week, probably. Maybe it drops on Friday and Saturday because people go to the pub or something instead. And then there is this block of people who are playing with something on their weekend in their free time. And it can be either larger than the weekday stuff. That means they don't get to use it at work at all, and they can only play with it during the weekend. Or it might be really small, and these are the poor souls who are probably stuck somewhere at work during the weekend finishing some critical project. So I will compare basically the ratio between weekday traffic and weekend traffic to certain hashtags. So if it's larger than 1, that means people are playing with the technology more on the weekend. And if it's smaller than 1, that means it's just the work-related stuff. So do you have any tips? What would be the most weekend thing you could do? What do you play with on the weekend? Yes? Haskell? It's actually, well, I will show you later. But, so this is my weekend index. So there are some Haskell tips. Any other tips, what would you play with only during your free time? Closure. Well, I will get back to functional languages a bit later. So this is the result, the top 5 weekend-only things. So Minecraft is something that people don't do at work. And you can see that the weekend index is larger than 1. So there is much more people asking questions about Minecraft programming on weekend. And then LWJGL, it's lightweight Java game library, SFML, D, and Pygame. So it's mostly about game programming. So I'm assuming it's people that are just playing with games in their free time. Any suggestions what would be the most boring corporate thing you would never do on a weekend?
Java.
Java, C, well. These are all tags, so these things are a bit more specific even. But the most corporate thing that no one would do in their free time, in their free will, actually, it's SQL Server reporting services. And this appeared in the top 5 2 times for 2 different versions. So if you have to do something like this over the weekend, poor you. So let's look at the most common tags, actually. They are all around 0.5. That means the traffic or the number of questions asked on a weekend drops to about half compared to a weekday. And the most free time of them is actually PHP and Python, about the same. But this doesn't really tell me much because it's all relatively similar. Then I decided to look at some similar technologies. For example, for continuous integration, people use quite a lot of Jenkins and Travis. So how do these two compare? And actually, Travis has a weekend index of 0.6 versus Jenkins only about 0.2. And this is a very big difference. I think the reason is that when people work on open source, they probably put their code on GitHub. And with GitHub, it's very easy to set up Travis integration, and it's free for open source projects. So that's something that people would use for their open source and free time projects. Whereas with Jenkins, you have to host it yourself. So this is quite a lot of difference, and I think this tells you something. If you want people to play with your stuff in their free time, maybe you should make it as easy as possible to use for open source projects. Yeah, their icons are very, very similar, actually, but the way people use them is very different. And now I wanted to show you how you can actually play with the data yourself.
DevTernity to yeah, this one?
Yeah, what's the password?
The best conference. The best conference.
OK, let's see. Yeah, downstairs there was different Wi-Fi. I'll go back here. OK. Or I can use my 4G. Probably. Still connecting.
Ah.
Sorry for that.
No problem.
Anyway, I might get back to this.
Yeah, good. Online.
Yeah, it connected. Good. So, come on. Yeah, if you go to notebooks.azure.com/Evelina, Azure actually provides free hosting for Jupyter notebooks. And who knows Jupyter notebooks here? Oh, about a quarter of the people. So Jupyter notebooks are an environment where you can usually write Python or R code. I will just create a notebook. And on Azure, you can actually create free public notebooks. And I'll create an Fsharp notebook. OK, so let's have a look how it looks. And here, you can actually write code and evaluate it. I can do 1 + 2, press Control-Enter, and it evaluates it, and it prints the result directly underneath. And what's really nice here is because something you don't get in R and things like that, you can actually use, for example, I can create an array and do array dot, and it tells me what I can actually use. So because Fsharp is a statically typed language, it has all these methods and things like that. So I can use a map, and it tells me what are the types, etc. So I can run something like this, and it, oh, it's a list. And I can get the results directly underneath. And I can also mix and match code and comments and things like that. So I will show you what I actually wanted to go to. And this is my Stack Overflow data, and this is the weekend ratio. And now here I can actually run the code, download libraries I will need. And you can go to the address that I showed you and actually run all the code yourself. And you can see that all the cells, they run. I just press Control-Enter. And all the auto-completion works as well. So if I, for example, delete this, this is the type provider that I was showing you before. It's a CSV type provider here. And I can select all the columns and rows there as well. So you can go and play with it yourself. And I'll just quickly run through the code. These are the weekend indices for different languages. So these are the most weekend technologies, Minecraft, etc. These are the most weekday technologies. And now I can compare different technologies together. So there was a question on Haskell and Clojure, etc., how weekend or weekday they are. So this is a random selection of functional languages. And it shows me their weekend index. So here is Fsharp, the top one is Elm. And you can see that Elm actually has an index larger than 1, which means that people actually play with Elm more in their free time, more in their weekends, etc. And Haskell is the second most weekend language. So people are definitely asking many more Haskell questions over the weekend than they are over weekday. I can also create a nicer plot. Yeah, this is one where I'm actually showing the one as a threshold. And as I said, you can actually, yeah, here I'm comparing some data science related languages. So R, Python, Scala, MATLAB, SAS, Fsharp, Excel, and Julia. And you can see that the most corporate ones, or the ones people don't really play with during the weekend, are SAS and Excel, which also makes sense. One interesting observation is that actually people who do data science, they generally ask less questions on the weekend than people who do functional programming. So maybe if you do functional programming, you should switch to data science and enjoy your weekends. So here, I can actually put my own languages. Is there some language you would like to see their weekend index, how it compares? Java. I'm not sure what's the correct tag. Objective-C.
Swift. Okay.
Yeah. So I had COBOL in there, because why not? And actually, Java is much more weekend than C#. So if you are doing Java, you probably have more fun with it than if you are doing C#. But C# is still more fun than COBOL. Well, you can go to the notebook, clone it, and run it for yourself to see how your favorite language compares. So let's go back to the talk, actually. So, yeah. So what next? I looked at tags. So what kind of data is there on Stack Overflow as well? I looked at some profiles on Stack Overflow, and I realized that people report their location quite a lot. And I thought, oh, that's nice. I go to quite a lot of conferences, and if I go to a conference, I want to know if I will find some like Java programmers or C# programmers or F# programmers. Who am I actually likely to find in different countries? So what do you do here in Latvia, for example? So I thought, OK, I can see where people who ask questions about certain technologies and answer questions about certain technologies are located. This should be fun. So my second question was, where are actually people located? And then, well, this field in profile is not compulsory. You don't have to fill in their precise location there. And I thought, OK, people will just leave this blank or put in some like, rubbish information. But I actually realized that, well, my data set had over 5 million users, and 770,000 of them filled in their location. So I thought, OK, that's good. That's 15%. And if you have a 15% sample of population, that's quite a lot for me as a statistician. So I thought, OK, this should give me kind of representative sample of the people, where they are located. So some of the things that people filled in were rubbish, of course. Things like $home, well, home location. But 83% of the people filled in something that I could match to a country in the world, to a specific country. Things like, unfortunately, Germany, well, still Germany. So I was happy. 83% of the people I could locate directly. But this left me about 120,000 people that I couldn't locate easily. But I looked at some of the actual things listed. And it's interesting that some people fill in their location very precisely, up to their office number. Because they probably think that someone will come and knock on their door and say, thank you for the answer, it was so helpful. Some people fill in their location very, very specifically, but probably no one will go and knock on their door because it's in Antarctica. I'm not sure this person actually lives there, but it's completely fascinating that someone is asking Stack Overflow question in a place like this. But then some of the locations were things like New York, Los Angeles, Riga, where it's pretty obvious where that is, which country it's in, but I couldn't really match it to a specific country directly. So what could I do? Well, I decided to use F# again. And because I'm talking about type providers, I decided to use type providers. And there are various location services that you can use online, various REST-based services usually. And I decided to go for Bing search because that one gave me 250,000 requests for free. And I had 120,000 users that I needed to locate. So I had 2 attempts. But I needed only 1, because I'm using F# and type providers. And this is a REST-based service, so it returns a JSON. And as before with the CSV file, okay, Bing search, I can create something called JSON provider and give it an example request. So now this is the address of an example REST request, and I created a JSON provider based on that. And it actually goes there, looks at the JSON, looks at the structure, and gives me the whole structure, including type information, in my type system here. So now I can just quickly write a function to locate a place. So let's locate X. And let's just call the type provider. And load, I will just copy this. Let's load this. And here I gave it Prague, because I'm from Prague originally, but let's give it X now. And this is basically all I need to do, because I will type result dot, and it tells me everything that's in the JSON. So this is quite an ugly JSON. So I remember that I need to go into resource sets, and then go through the resources. And the resource is, again, an array of things. And if I do r dot, come on. Did I do something incorrectly? Now, this depends on the internet here as well. So, oh, I wanted to go into resources. This is it. OK, and here I have address, bounding box, geocode, etc. But I'm interested in the address, and in the address, I have the country region. So this will give me the country where any location is located. So I'll just change this a little and collect the results. I haven't run anything yet. This is all in my type system, and now I know that locate is a function that takes an x, which is a string, and returns an array of strings. It returns 5 closest countries to the location that I will give it. So let's actually evaluate this. And I'm running this in my Fsharp Interactive done underneath here. And let's test this. Locate Riga. And Riga is most likely in Latvia. Yes. I lived in Cambridge, so let's test Cambridge. And Cambridge is, the first one is in the United Kingdom. Yes, that's mine. And the second one is in the US. And that's correct, because all the best universities in the world are in Cambridge, because MIT is in Cambridge, Massachusetts. OK, so it gave me some interesting results. For example, the universe. Do you know where the universe is? It's actually in United Arab Emirates, because they have some kind of artificial islands that they call the universe. And if you want to know where is your home, home is in Canada, because they actually have a home island in the Arctic. So you probably don't want to go home if you don't like cold. So this allowed me to actually locate all the remaining users that I had. So where are, for example, F# people? And it gave me a map like this. So most people using F# are in the US, and then in the UK, and the rest of the world, yeah, there are some, but not that many. And I thought, OK, this is kind of boring. I know that in the US, there are probably the most programmers in the world, like the total number of programmers. So this is not interesting, right? So I thought, OK, so how do I find out where the people are really located? If I go to programming conferences, how likely am I to find an F# programmer? So I actually devised an equation where if you scale the number of users that are registered on Stack Overflow from a specific country with the total population of a country, etc., and how likely people are to register, you get something like this. And the unit of this is programmers per million. It's not a very reliable measure, but if I can get a population of each country, I will know how many programmers per million inhabitants there are. So where are people really located? And for this, I need to get population of each country. I suppose I could go to something like Wikipedia, copy it over into a file, and then use it in my data. But I'm using type providers. And now you can probably see the pattern. There is something called HTML type provider, which allows me direct access and type-safe access to HTML files. So here I have URL for Wikipedia. And I will create a type out of that. And this is HTML, so I will create HTML provider and give it the URL. And load the actual article. So if I now type wiki, and this depends on internet, definitely, it tells me, OK, I can have a look at the HTML code, or I can look at lists on that website, or I can look at tables. And I'm interested in tables. And if I do another dot, it tells me which tables are on that website. And this Wikipedia article contains a table called countries and dependencies by population. And that's exactly what I want. So let's get this. And now I can do table, rows, and I can iterate through the rows. And if I do row, I don't know still what are the columns there. But if I type another dot, it tells me there are columns that are called the percent of world population, country name, the date, the actual population, and the rank and the source. So I can, for example, look at the country, and I can look at the percent of world population. And if I run this, this should work. OK, let's run everything. And now this gives me, as a result, all the countries and what percent of world population they have. So the first one is China, which has 18% of world population. And I didn't even have to look at the website, which is amazing. Whenever you are scraping some website, you usually have to have it open on one side and code on the other so that you know what you are referring to. But here, I just didn't even have to look at it. So this was extremely useful. And I found out where people really are located. So where are they really? So F# programmers, most of them are actually, they are more likely to be in Denmark, which is nice. And it makes sense because they actually teach F# at the university. So I know that Denmark is the place where I need to go if I want to find F# programmers. And I actually have the code here. So let's run this. And it should open a plot. Yeah. Waiting for Google. So this is the plot, and I know that in Denmark there should be 71 programmers per million. And now I looked at Latvia, and there are less F# programmers than in Estonia, for example. So I think you should all learn F#. And then I thought, OK, so is this actually telling me the truth? So I decided to look up something that probably will have some kind of regional effect. For example, Erlang, because this originated in Sweden. And Sweden and China jumped up as the places where there are more Erlang programmers on average. So then I looked at, for example, COBOL, because why not? And COBOL is most likely located here. I think you probably can't really see that, because that's the little country right here, the little here, Luxembourg. And because they have a lot of legacy bank systems written in COBOL, that means in Luxembourg they have a lot of COBOL programmers. So I was very excited that this whole thing works. And if you want to look at your favorite language, you can actually go to my Azure notebook again, and there is a population distribution notebook where you can run all the code and actually display your own favorite language. I won't go through that, but it will give you a map with distribution. So this is much more fun, because now I know that if I want to find F# programmers, I know where to go. The interesting thing is that, for example, some countries jumped up a lot as sort of outliers in this. I can, for example, look at which languages are most common in Latvia. So here I have some code that runs that, and it's going through all the tags. And most common is JavaScript, then PHP, then jQuery, then HTML, SQL, CSS, Java, etc. So not very interesting, or it's things that are probably more common across the world. So I could also look at outliers. And some countries that jumped up as outliers for a lot of languages were the Dominican Republic. And I wondered if it's all the digital nomads actually going to code on a beach and things like that. And then actually someone sent me an email saying, I'm from Dominican Republic, we don't have that many programmers here, actually. So I thought, OK, it's probably something else. And the problem is that there is a huge sampling bias in this. Because here I am expecting that people are likely to register and put in their location with the same likelihood across different countries. And I know that, for example, us from Eastern Europe, we are a bit more paranoid than people in the US, and we are less likely to put in our location into any kind of system. By the way, the only country where people put in their office numbers and very precise locations was India. So I guess in India they want to be found. We usually don't want to be found in case the government decides to find us. So there is a huge sampling bias. But for the larger countries, I think this works pretty well because it gives me reasonable results. And that's one advantage of working with interpretable data compared to the biology. Because I looked at the data, for example, for the air-lung, and I see it's in Sweden, which makes sense. So I know that it's at least partially right. So I looked at the tags, and I looked at users or their locations. But actually, tags and users together give me sort of communities. Because if two users answer and ask questions regarding the same technology, they are in the same community, probably. So I can use this, and the tags will define relations between users, which is extremely interesting in some way. So this is me and my friend Krzysztof from Poland, and I can formalize this. I can create a sort of binary matrix where each row corresponds to a user and each column corresponds to a technology. And I use F#, he uses F#, I don't use C#, he used C# before he found F#. Everyone uses JavaScript in some way. I use R, he doesn't, and none of us uses COBOL. So this gives me a very nice matrix or formalization where I can look at rows, and if they are similar, I know that the users use the same technologies. And if I look at technologies, if they have similar columns, that means there is a similar pattern between users who use them. So altogether, I had a rather large binary matrix, and it was very sparse. That means it didn't have a lot of data. So what I did, I actually looked at only power users and more common tags. And this gave me a matrix of 1,600 times 800. And I could look at how technologies are related. And whenever you are working with data, you should always try to visualize them. So how do I visualize a 1,600 dimensional space? Imagine 1,600 dimensional space. That's kind of not very useful, right? So I decided to use something called tsni. And this is a very popular representation for data if you want to see if your data makes sense, because you can clearly see relations between data. And the thing, this tsni, it's the T-distributed stochastic neighborhood embedding. And that's quite a mouthful. But the key word here is embedding, because it's a method that embeds the 1,600 dimensional space into a two-dimensional space that I can actually visualize in a meaningful way. So it's embedding into a visualization. And if you imagine a high-dimensional space, usually the data, if they are not completely random, they are located on a subspace in the 1,600 dimensional space in this case. And what tsni does, I'll just give you a very rough idea. It looks at points in the space, and for example, these 2 points, they are quite close in the high-dimensional space. But if you look at it in the logic of the data, they are very distant. So what tsni does, it looks at just the local neighborhood of each point, and it tries to optimize that so that points that are close to each other will stay close to each other in the visualization, and points that are far from each other, they will be like anywhere in the visualization. So to do that, to do something like this, you probably don't want to program it yourself. And if I wanted to do it, I would probably do it in R or Python. And in R, you just load a library called tsni and call a function called tsni. But I had all my data in F#. But type providers to the rescue again, because in F# you can use something called R provider, which gives me access to all functions in R. And all I have to do is just open the R provider and call rprovider.tsni, and then in my call r.tsni, and I will get the same thing. It will run R underneath and give me results back into F#. So this is really nice. And why would I do that if I can just run it in R and plot it in R? I can do R plot. Well, if you plot something in R, something as huge as this, you get something like this. So these are all the technologies and how they are related in 2D. Amazing, right? Are you amazed? Well, the problem is that the best thing about R is that it was written by statisticians, and the worst thing about R is that it was written by statisticians. So if you have something like this, you probably don't want to visualize this in R, and what we would do is you would probably go to something like D3 and use JavaScript. But I had everything in Fsharp, and that's why I used something called Fable. And this is a compiler from Fsharp into JavaScript. So I could actually write my code in Fsharp called D3 visualization from Fsharp and have it in JavaScript. So this is how it actually looks if you plot it properly, because then you can do things like ensure that labels don't overlap with each other, and you can actually read them. And if I zoom into it, this is an example of one cluster from the visualization. And you can see that it's all Android in the top. So it collected all the Android tags into one location. So all the people who program Android are here. And it knows that they are related because the same kind of people use these tags for questions and answers. This is another cluster of people doing Node and JavaScript. You can see Node and JavaScript in the top. Angular, Canvas, etc. So all the tags that are in some way related to Node and JavaScript. And this is a small cluster of people who are probably confused about object-oriented programming. Here, polymorphisms, constructors, inheritance, etc. They should use functional programming. Now I know who to target. And this is quite fun to use even in my bioinformatics work, because this is an example of visualization of human genomes, of locations where human genomes differ from each other in different nationalities. And this is where they put it into a t-SNE visualization. And for example, the red blob down here are all the Chinese population, and half of them are from the US, half of them are from China. And it's actually in one blob, but it's slightly separated. So you can see that the two populations are very similar, but slightly different. So it can give you a quick look at the data. And this is extremely useful and extremely fun, actually. So I had tags, users, and technologies. I actually didn't look at the questions and answers. I need to check when is my talk actually finishing. Sorry. So that I have enough time to go through everything, and I don't. So I will just show you some quick example. I was talking about embedding before, about embedding into a visualization. So I decided to use a different kind of embedding, to look at word embedding. And the most probably famous or most used method for this is called word2vec. And it's a method to use words and create vectors out of them. So it's an embedding. Like before, t-SNE was embedding from points and local neighborhoods into 2D space. Word2vec is actually an embedding of words and their local context in sentences into numbers. And if I have numbers and vectors, I can do arithmetics with them. And I can do, OK, so what would be, for example, C# minus .NET and things like that. And it's a lot of fun. It's actually using neural networks, not deep neural networks. It's actually a shallow neural network. But I don't want to go into details. And the nice thing is the typical example is you take a king and subtract a man and add a woman. This kind of embedding will give you, OK, this is a queen. Because if you take a king, subtract man, and add woman, you get a queen. So it creates kind of representation of words. And the way it knows that is that it looks at sentences. For example, Fsharp is a functional language on a .NET platform, and Scala is a functional or more object-oriented language on a JVM. So it knows that they are languages because they are surrounded by the word language quite a lot, and they are surrounded by the word functional language. So if two words are surrounded by similar words in different contexts, that means they are related. And As I said, I can do now arithmetics. I can do Scala minus JVM plus .NET. What do you think I will get? C#. And the second closest hit is F#, actually. So another thing, if I take F# and subtract .NET, Haskell, well, Haskell is a functional language, but it's not like F#, actually. So the closest one is SML, which is standard ML. And the reason is F# is an ML language. It's in the ML family. So actually, Haskell is only the fourth closest thing to F# minus .NET. So you can see that it managed to extract quite a lot of relations from the languages and from how people talk about the languages. This doesn't know anything about how the languages actually look. It only knows how people talk about them and what kind of questions and answers people ask. So it's used quite a lot in the bioinformatics area as well. So there are a lot of papers. They try to translate things from, for example, biomedical literature to get in representation of genes, how they are represented in literature. So it's extremely useful. So to wrap up, I was talking quite a lot about F#, but what I believe in, I was using JavaScript and R from F# in my case, but I really think that if you want to get something done in data science, you just need some tool for the job. So just use whatever you are most productive in. In my case, this was F# because I had to start preprocessing data from scratch. And you could see that type providers are extremely useful for that. And on the data science side of things, I think a lot of people ask me about how should I actually start with data science. I'm extremely interested. What should I do? And I think the best thing is to pick something that you are interested in and start asking questions, because that will drive you to explore the data more and get information from there. And you can see that you can get quite far even with things like Word2Vec, and implementations of Word2Vec are in all languages, basically, so you can just play with that and get quite interesting information from there. And if you want to ping me, just ping me on Twitter, and this is my website, and thank you.